Alright, what's happening, y'all? We're going to give another geometry puzzle a shot. This one has to do with hexagons, which is a very nice shape. The goal of this one is to figure out the length of this pink line, going from the corner of this hexagon to the corner of this hexagon, knowing that this black line is 6 units long. We also know that both hexagons are regular, which means all of the sides are the same length. Give the video a pause and try it yourself if you feel like it. Cool, so I'm going to be doing a lot of drawing on these hexagons, so bear with me. Sort of the crux of our argument here is going to be similarity between two triangles, which I can draw here. So I'm going to make this line go straight across, form a 90-degree angle with this little side here. We're going to try and prove similarity with this very similar looking triangle that's upside down comparatively right here. The hypotenuses being this 6 length side and the pink line, which we're trying to figure out. I'm going to draw another couple lines here that I think will be helpful in solving this. I'm going to make a rectangle that goes down to where these two hexagons meet, that point on the corner. And then I'm going to draw another rectangle. These are sort of tough. It goes straight across, and it should go and meet up with this other rectangle. So now we've got 2 rectangles on the screen as well as these 2 triangles, and the goal is going to be to try and prove triangle similarity here. Alright, so we can pretty easily see a relationship between the 2 bases of these triangles. So this base goes all the way across both shapes, right? So it's the full width of both shapes, and this line of this triangle goes halfway across the smaller hexagon and then halfway across the larger hexagon. So we know that if this length is x, then this length is 2x, right out the gate. So if we're trying to prove triangle similarity, we're going to try and prove that this triangle is twice as big as this one. We already know for a fact that this side is twice as big as this side. We also know some other things about hexagons, especially regular hexagons. Every angle in a hexagon is 120 degrees. So this angle up here is 120. Every single angle, all the angles in the smaller hexagon, all these are 120. We know that. So knowing that this angle is 90 degrees right here, and this whole angle was 120 degrees, then this little angle has to be 30 degrees. And then this angle, because there's this side going up here, is split in half, and so this angle is 60 degrees. So up at the top of the house looking thing up here, we have a 30, 60, 90 triangle, and there's kind of a few of those in the shape at this point. So now we're going to talk about a lot of different relationships in these shapes. So 30, 60, 90 triangles have a pretty special relationship. The shortest side, or the side across from the 30-degree angle, which I'm going to highlight in a different color here. So let's make this height right here blue. So that side right there, let's call that y. The hypotenuse in a 30, 60, 90 triangle is twice whatever the height here is. So this side would be 2y. And all of the lengths of the sides in the hexagon are all 2y because they're all the same length. It's a regular hexagon. And so we could describe this whole side as 2y as well because all of the sides are the same. And we have a similar thing happening in the smaller triangle. So if we call this height right here z, then this side is 2z right here. And if that side is 2z, then this side is 2z over here, right? And if this side of this rectangle is z, then this piece of this rectangle is z, right? So we could actually represent the height of our original triangle as this green piece right here as y minus z. We could represent this piece of our original triangle, the bigger one, as 2y minus 2z. And so this equation is very clearly double this equation, 2x, it's pretty clearly double x. And if we got two sides with similarity with a ratio of 2, the last side must have a ratio of 2. So this 6, we double that to figure this out. That's going to give us 12. And that's the length of our pink side. Cracked another one. Thanks for watching. Catch you later.